A 20-foot ladder is leaning against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle of elevation of the ladder? How high does the ladder reach on the building? The first step to solve any problem is to see if we can draw a diagram. We have a vertical building, assume, not a leaning building, and the ladder is leaning against a building, and so this is the ladder, and this ladder is 20 feet long, and so this distance is fixed. The base of the ladder, the bottom of the ladder, is 6 feet from the building, and so this distance is 6. What is the angle of elevation of the ladder? Remember that the angle of elevation is the angle that we looked up from the horizon. And so we call this angle theta for now. How high is the ladder reach on the building? Meaning we're looking for this distance, which we will call it h. This is a right triangle. Using the trigonometry of right triangle, we have the angle theta along with the adjacent side and the hypotenuse. Because the adjacent and the hypotenuse informations are known in the problem, we would use cosine. Cosine of the angle theta equals adjacent over hypotenuse, which is 6/20. To find theta, we use inverse trigonometric functions. Cosine of theta equals 6/20, meaning theta equals cosine inverse of 6/20. And to use a calculator, we evaluate cosine inverse of 6/20. We'll get approximately, in degrees, 62.54 degrees, and that is the angle of elevation. To answer the second part of this problem, knowing that this is the right triangle, we can just simply use the Pythagorean theorem, which states that the hypotenuse square, 20 squared, equals the sum of the other two sides squared, 6 squared plus h squared. And so h squared equals 20 squared minus 6 squared. H is therefore the square root of 20 squared minus 6 squared, which is 364. This is approximately 19.08. The unit is feet.